Hi, this is Venkatram Seshu Samavedam. I am working as a chemistry faculty from last 20 years in different repeated institutions. Now I am working as a senior faculty in Akash, Himayat Nagar from last 8 years. Today I am going to explain concept of dipole moment. So what is a dipole moment and what is its concept? So first of all, if you want to know about dipole moment, we have to know about polar covalent bond. Polar covalent bond. So what is polar covalent bond? The covalent bond which is formed between two atoms having different electronegativities. Let us take an example. Take a general example. If I take hydrogen and fluorine. So here hydrogen is having electronegativity 2.1. Fluorine is having electronegativities 4 according to Pauling scale of electronegativity. Then here what will happen? The shared pair of electron. See, we know that more electronegative atom is fluorine, then the shared pair of electron is migrating towards fluorine. That means this dipole moment is a vector quantity. That means it is based on the direction of the migration of electron density towards any one of the bonded atom. Now you see here there develops a partial negative charge. There develops partial positive charge. The partial positive charge on hydrogen atom, partial negative charge on fluorine atom. Then the bond which is said to be polar covalent bond. Then the molecule is said to be polar molecule. So this polarity in the molecule, can be expressed in terms of dipole. It will be represented with the letter mu. That means if we take H and HCl molecule, it is polar. If we take sulfur dioxide, it is also polar. Sometimes we have carbon dioxide, which is a non-polar molecule. If you take BF3 molecule, which is a non-polar molecule. That means a molecule is polar or non-polar, that is completely based on the resultant migration of electron density towards more electronegative atom. So sometimes we can get only one bond moment. Based on one bond moment, we can calculate polarity in the molecule. Sometimes based on two or more bonds, we can explain the polarity in the given molecule. So the complete polarity in the given molecule can be explained by using dipole moment concept. So what is a dipole moment? How we can explain? Dipole moment mu. If I take hydrogen and fluorine, towards fluorine atom, the migration of electron density takes place. That migration can be represented with arrow. They develop partial negative charge on fluorine atom and partial positive charge on hydrogen atom. That means this is in between pure covalent bond and ionic bond. Whatever the polar covalent bond is there, that polar covalent bond is in between pure covalent bond and an ionic bond. In this case, there is no complete bond breaking between the two atoms. There exists only migration of electron density takes place from less electronegative atom to more electronegative. Because of the development of partial charges on the atoms, how can we express dipole moment? So dipole moment can be calculated by using formula charge magnitude on the dipolar ion. So how much charge is present on any one of the ion in a dipole into distance between two polar ions. So if you take vector quantity, it depends on the direction and it depends on magnitude, both magnitude and the direction. So here, in which direction it is migrating, and what is the magnitude on the charge. Based on the magnitude on the charge which existing on the particular more electronegative atom and the distance between two polar ions, you will get a polarity in the molecule. That polarity can be expressed in terms of dipole moment, that is directly equal to Q into D. So this Q, in general, they will take 10 to the power of 8 electrostatic units. Sorry, 10 power minus 10 electrostatic units. And D, that is about 10 to the power of 8 centimeters. That is directly equal to 10 power minus 18 electrostatic units to centimeters. So let us assume if I take a charge on the particular dipolar ion is 10 power minus 10 electrostatic units, and the distance between two dipolar ions is about 10 power minus 18, then that is directly equal to 1 dB. That means dipole moment can be expressed in terms of dB. If you take 1 dB, 1 dB is equal to 10 power minus 18 electrostatic units to centimeters, or sometimes they will take 3.33 into 10 power minus 30 coulombometer. So what is dB? dB is the unit of dipole moment. Dipole moment units are dB. Generally, dBA is nothing but electrostatic units to centimeters, that is 10 power minus 18. In terms of Coulomb meter, that is 3.33 into 10 to the power of minus 30 Coulomb meter. So that means if you know the charge on the particular hydrogen atom, you can easily dipolar ion, you can easily calculate based on the charge magnitude and the distance between two polar ions, you can easily explain the dipole moment concept. That means must and should you have to know about the charge and you have to know about the distance between the two polar ions. This is about dipole. So based on this, if mu value, if you got the mu value which is equal to 0, then the molecule is a non-polar molecule. If mu value which is not equal to 0, then only the molecule is polar molecule. So how can we find out? We have different types of molecules. How can we find out dipole moment? We have different cases. So in terms of cases, I will explain. Case 1. Only one similar, only one bond between two atoms in a given molecule. That means in the case of diatomic molecules, let us take in the case of diatomic molecules. Only in the case of diatomic molecules. How can we say dipole moment? Example, you take, I will change the example, H and Cl I will take. Here, Cl gets partial negative charge and hydrogen gets partial positive charge, then it is said to be polar molecule. So now I have to find out the different concepts in this dipole moment. So if I want to find out that, first point is that if H and Cl is there, here delta, here plus delta, then simply we can find out dipole moment mu. Mu is nothing but dipole moment. So the dipole moment is what? Q into D. If you know the charge and the distance, we can easily find out. So if you know dipole moment, sometimes they will give observed dipole moment. Sometimes they will ask percentage of ionic character. So the bond is polarized, how much it is polarized? How can we find out mu observed by mu calculated into 100? But how can you get mu observed? Mu observed, they will give value in the question. I will discuss few questions in later. Q into D. So here charge of the electron, sir, how much charge we have to take? Charge of the electron, that is 4.8 into 10 to the power of minus 10 electrostatic units, or 1.602 into 10 power minus 19 coulombs. That means based on the particular charge, we have to take charge of the electron 4.8 into 10 power minus 10, 1.602 into 10 power minus 19 in terms of electrostatic units and coulombs. Sir, why are you taking charge of the electron? I am expecting polarity 100%. That means I am expecting charge on the Cl minus is about 1 electron charge, but I will not get that much. Why? Because it is partially polarized. That is why whenever we are taking the value of mu calculated, 100% what we have to take by the use of charge of the electron only, you have to find out. Mu calculated, mu observed nothing but they will give the value, then finally you can get percentage of ionic character. So in the similar way, sometimes they will ask percentage of covalent character. If you want percentage of covalent character, simply we have to subtract percentage of ionic character from the total value, 100. Then you will get percentage covalent character. Sometimes if you want to find out percentage of ionic character, based on the electronegativity also we have to calculate. We can calculate 16 into Xa minus Xb plus 3.5 into Xa minus Xb whole square. So it is based on electronegativity, sir. Since what is Xa? Xa is nothing but electronegativity of more electronegative atom. What is Xb? Xb is nothing but electronegativity of less electronegative atom. If you know both electronegativities, we can easily calculate percentage of ionic character. So that means in the first formula, directly we can calculate dipole moment. After getting the dipole moment, or after giving the observed dipole moment, what they are observed in the observed experimentally. Sometimes they will ask percentage of ionic character. That percentage of ionic character we can calculate by using mu observed by mu calculated into 100. So if you want to find out the covalent character, 100%, what we have to do? Total ionic character is expected is 100, but it is not happening. Then whatever the ionic character we are getting, it may be 60% or 30%. That ionic character you have to subtract from 100, then you will get percentage of covalent character. Sometimes based on the electronegativities, they will ask the questions, if you know electronegativity of more electronegative atom and electronegativity of less electronegative atom, simply percentage of ionic character, then we can easily find out by using 16 into Xa minus Xb plus 3.5 into Xa minus Xb whole square. Remember these three formulas. These three formulas are very, very important to find out different concepts they will ask in the dipole moment. Now you see, if you want to find out percentage electronic charge, percentage electronic charge exists on dipolar ion. So percentage of electronic charge, if you want to find out, simply what we have to do, how much charge we got, we observed, by how much we are expecting. We are expecting charge of the electron, that you have to multiply with 100. Then it is directly equal to percentage of ionic character. Then it is directly equal to percentage of ionic character. Very simple. If you want to find out percentage of electronic charge, directly you can calculate by using percentage of ionic character. Sometimes percentage of ionic character is directly equal to percentage of electronic charge existing on the dipolar ion. If you want fractional electronic charge, fractional electronic charge on the ion, you want fractional charge. Fractional charge is nothing but what? Q observed by charge of the electron. Then if you multiply with 100, then it is percentage of electronic charge, that is directly equal to percentage of ionic character. If only one bond is there, we have to use all these formulas to find out the dipole moment, to find out the ionic character, to find out the particular covalent character and percentage electronic charge existing on the dipolar ion. Now I will go to case 2. If we take case 2, for multi-atomic molecules, that means greater than that of 2 atoms are present in the given molecule. Let us take if I take BF3 molecule, if I take carbon dioxide molecule, if I take a XeF4 molecule, if I take a XeF2 molecule, If I take BeCl2 molecule, these are multi-atomic molecules, more than 2 atoms present. If I take BF3, here 3 bonds are present. In this case, instead of taking dipole moment, we have to call it as the resultant dipole moment, mu resultant, which is equal to 0. In the case of carbon dioxide, here also mu resultant, which is equal to 0. In the case of XeF4, sometimes lone pairs I am taking. Here also mu resultant, which is equal to 0. In the case of XeF2, here lone pairs. We have to know trigonal bipyramidal structure. Here also mu resultant, which is equal to 0. That means these molecules are having mu resultant, which is equal to 0. Then they are said to be non-polar molecules. But the bonds are polar, but the molecule is non-polar. Why? Why? That is based on the resultant dipole moment. How can we find out the resultant dipole moment? What is the formula we can use to find out resultant dipole moment? Let us take an example. If I have BeCl2, towards chlorine atom, the migration of electron density takes place. Let us take the bond moment of the first bond, I will take it as X, and the bond moment of the next bond, I will take it as X. Both are same, but opposite direction. But whenever I am using the first formula, let us take the first formula. If you want to find out mu resultant, when 2 bonds are existed, both bonds are similar type, then I can use formula mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. So that means here you have to know about the theta value. Here, what is the theta? 180 degrees. So here, if I take, if theta is 0 degrees, then what I will get? Mu resultant, which is directly equal to square root of mu1 square plus mu2 square plus 2 mu1 mu2 cos 0 degrees. Cos 0 is -1. So then, sorry, cos 0 is 1. Then what you will get? Mu1 plus mu2 whole square. Then what you will get? Mu1 plus mu2. The resultant dipole moment, if I take above equation, that is 2x. 0 degrees, nothing but same direction. Both bonds are same direction. Then the dipole moments added together. If theta is 180 degrees, then what is mu resultant? Mu resultant is directly equal to mu1 square plus mu2 square plus 2 mu1 mu2 cos 180 degrees. Just I told cos 0 -1, that is wrong. Here, there cos 0 is 1. Here cos 180 degrees is what? -1. You will get square root of mu1 minus mu2 whole square. Why? Because cos 180 degrees is -1. Then according to that formula, mu1 square plus mu2 square plus mu1 square plus mu2 square minus 2 mu1 mu2, then it is said to be mu1 minus mu2 whole square. It is like a minus b whole square. Above case, a plus b whole square. Then what you will get? The resultant dipole moment, mu1 minus mu2, that is x minus x, which is equal to 0. So if theta is 180, if similar type of bonds are there, I got the molecule is non-polar. If theta is 0 degrees, here the bond moments added together, then the molecule is said to be polar. Like that I can explain BeCl2. Why? here BeCl2, why mu value which is equal to 0, mu resultant is mu1 minus mu2. Here only you have to consider the magnitude x minus x is equal to 0. Then what is the BeCl2, polar or non-polar? Non-polar molecule. So same example, I can explain by using another formula also. To that I will take another formula to explain BF3 molecule, why it is a non-polar molecule. So this is also one polyatomic molecule. If you see between any two bonds, the bond angle is 120 degrees. If you want to find out the resultant bond moment when the bonds are similar type, here you see bond moment, boron to fluorine is X, here also boron to fluorine is X, here also boron to fluorine is X. But here two bonds are exactly moving opposite to one bond. In this one bond, the bond moment it is showing X. But here in two bonds, if I want to find out the bond moment, we have to use a formula 2 into bond moment into cos theta by 2. This is a formula. Another formula we can apply. Not only in this case, we can apply in the above case also, but I am including another formula here. Then what I can say here, I know already it is X. I have to know about mu resultant in the bottom one. So here bottom two fluorine atoms are dragging the electron density towards downward direction. Then mu resultant is equal to 2 into, if I take bond moment is X, I will get cos 120 degrees divided by 2. Then that is 2x cos 60 degrees. Then cos 60 degrees is 1 by 2. That is 2x into 1 by 2. That is equal to x. Then the mu resultant, what I can take x. But both are opposite. Then what is the bond moment? I will take minus x. Why? Because above bond is opposite to below two bonds. Then mu result I can, to find out mu resultant, I am using this formula. Then total dipole moment, resultant dipole moment is what? Mu total. So I will take this x as mu1 minus mu resultant. Mu1 is x. Minus x. Only consider the magnitude, that is equal to 0. Why? Because opposite. This is also x. Both are opposite. That is why minus sign I am using. Or otherwise, don't take minus x into minus x. So sorry, x minus of minus x. Here x opposite. Like this also I can cancel it. Or otherwise I can take mu1 minus mu resultant. Mu resultant is x I got, and mu1 is already x. X minus x is equal to 0. Then the molecule is non-polar. So this is another formula we can use to explain the dipole moment. So finally, based on this formula, I can use the resultant dipole moment, whether the molecule is polar or non-polar. Like that, so many problems we can do using all these concepts. Now I am going to explain few molecules, polarity, based on different concepts. So theoretically, if I want to explain a dipole moment, you see carbon oxygen polar bond. Here carbon oxygen polar bond. If I take towards this direction x, must and should opposite direction x, both are cancelled. Then here the mu resultant value 0. Then the molecule is non-polar. If I take a XeF4, bond moment is or polarity is not only caused by the bonds which are bonds which are having electronegativity difference between the two atoms, but also the lone pairs also causes the polarity in the given molecule. You see, both fluorine atoms opposite. If you take here, it is X and it is as minus X. If I take it is X and it is as minus X, and lone pair also causes bond moment or polarity in the electron density. If I take it as X, opposite direction, we can take it as minus X. All will be cancelled. Here also mu resultant, which is equal to 0. Like that, so many molecules we can explain. If I take S double bond O, S double bond O, lone pair, sulfur dioxide molecule. The bond moment caused by these oxygens, whatever the particular mu1 value, it is less than that of the bond moment or the electron density migration caused by the lone pair. So that is mu2. Here 100% mu2 is greater than mu1, then the molecule is said to be polar. That means the polarity in the given molecule caused by lone pair, that is more than that of the polarity caused by the bond pairs. Then the molecules are polar molecules. So when the molecule is polar molecule, then it is said to be permanent dipole. So what is permanent dipole? Permanent dipole is nothing but polar molecule. That we have to consider. So like that, we can explain different examples. So why XeF4 is non-polar, why XeF2 is non-polar, and why CO2 is non-polar, why SO2 is polar, why SO3 is non-polar. If I take SO3 molecule, double bond, same like BF3 structure. If I take BF3 structure, these two opposite, I will take minus X. This bond is X. Then mu resultant, which is equal to X minus X, which is equal to 0. Then the molecule is a non-polar molecule. So like that, I can explain different examples. I want to explain a few questions related to the dipole moment now. So I'm taking examples. Now I'm taking this example. This example I will take. See here, in this question, what they are asking, already they mentioned they gave chlorobenzene. In the chlorobenzene, they are mentioning the polarity towards chlorine atom. Here, mu value they mentioned 1.1D. This is very simple question. If you know BF3 molecule structure, simply you can easily explain it. Put a chlorine, here chlorine, here chlorine. These two bonds are exactly opposites. This is minus X and it is plus X. Both will be cancelled. Another bond is there that shows the dipole moment. That means if it is my 1.1, it is also 1.1, it is also 1.1. So minus and plus will be cancelled. Why? Because both are opposite. Here the dipole moment which is caused by only one chlorine atom, therefore both are same. The answer is first option. Like that, one question I can explain. I will go to the next question. I will take this question. It is completely based on percentage of ionic character. How can we find out the percentage of ionic character in the given molecule? Let us take AB. AB is a molecule they mentioned. So if I take AB molecule, there exists observed dipole moment. They mentioned observed dipole moment is 1.6 dB. That is 1.6 into 10 to the power of minus 18 electrostatic units to centimeters. Internuclear distance already given. D is given. Internuclear distance, that is 100 picometers. That is 100 into 10 to the power of minus 12 meters, which is directly equal to 10 power minus 8 centimeters. Sorry, 10 centimeters. So now you see, if I want to find out the percentage of ionic character, I will use the formula already told, mu observed by mu calculated into 100. Sir, how can you find out mu observed? Already mu observed is given, that is 1.6 D. Mu calculated, or you can write mu observed is 1.6 into 10 power minus 18 electrostatic unit centimeters. Same units we have to take. Then what I told, charge of the electron into distance. Charge of the electron 1.6 into 10 power minus 18 by charge of the electron. So here I am taking electrostatic units as centimeters. Whenever you take electrostatic units as centimeters, so simply 1.6 into 10 power minus 18 by 4.8 into 10 power minus 10 electrostatic units as centimeters. This is in electrostatic centimeters, and distance is 10 power minus 10. So picometers, which is given 100. Just we have to find out 18 10 power minus 12 meters. Then sorry, this is about a 10 to the power of minus 10 meters. That is 10 power minus 8 centimeters. Then it is 10 to the power of minus 8 centimeters. Initially what I wrote, that is correct, into 100. So because it is 100 into 10 power minus 12, that is 10 to the power of minus 10 meters. I have to convert the 10 power minus 10 meters into centimeters. That is 1 meter is 100 centimeters, then 10 to the power of minus 8 centimeters. Then what you will get, 10 power 18, 10 power minus 18 will be cancelled. Then 1.6 by 4.8 into 100. That is 1 by 3 into 100, which is about 33.33%. This is percentage of ionic character. This is one problem I am doing. This is done. Next, I will go to the next problem. What is that problem I am taking? So here they are asking percentage of ionic character. Same model problem they are asking. We'll go to the next problem. So here they are asking which of the following have maximum dipole moment? How can we find out the dipole moment? Same theoretically I can easily explain. It is very simple. In the first molecule, what is the first molecule they are giving? All chlorine atoms are in the same direction. So if it is X, if it is X, if it is X, with respect to these two chlorine atoms, the bond, the angle between chlorine and chlorine is 120. Already we calculated mu resultant, which is equal to what? 2 into bond moment into cos theta by 2. Then what we got? X. Therefore, to this molecule, mu resultant is equal to 2x. This is first case. Second case, it is very simple. If you take chlorine and here chlorine, both are opposite. No need to calculate anything. Both are opposite. X, mu value 0. If you take third case, it is also very simple. No need to calculate any by using any formula. So both are cancelled, but the dipole moment shown. These two are cancelled. Finally, the resultant dipole moment is equal to X. Here resultant dipole moment is 0. And if I take the fourth option, all chlorines are exactly like BF3 molecule. So here angle, how much? Here 120. Chlorine, chlorine. Same like BF3. If it is X, it shows minus X. Then what is mu resultant? Mu resultant is equal to 0. X minus X. So which is having maximum dipole moment. The maximum dipole moment shown by mu resultant to 2x. Maximum polarity dipole moment. First option is the right option. Like that, so many examples are there. We can calculate so many examples. Based on that, you can get clarity about the resultant dipole. So last but not least, sometimes as per NCERT, they will ask different questions. NF3 and NH3. If you take NF3 and NH3, both are having similar shape, pyramidal shape. The arrangement of electron pairs is tetrahedral, both bond pairs and lone pairs. But here, the dipole moment of NH3, which is greater than that of dipole moment of NF3. Why, they will ask. Why? Because in the case of NF3, all bond moments towards fluorine, therefore, the bond moments caused by the fluorine, I will take it as mu1. The bond moment caused by the lone pair, I will take it as mu2. Therefore, here, some of the bond moments caused by nitrogen and fluorine bond, which is neutralized by the bond moment caused by the lone pair. Therefore, the dipole moment, resultant dipole moment is low. But in the case of NH3, nitrogen is more electronegative atom. That means lone pair, in which direction it is polarizing the molecule, in the same direction the bond pairs also polarized. That means here all bond moments in only in one direction. Then mu resultant is high. But in this case, in the case of NF3, why the mu resultant is there? Some of the bond moments neutralized. Like that, they will ask different types of questions based on the questions what they are asking. 100% we have to follow. So this is about dipole moment concept. So maximum I discussed about all such type of points. So whenever the particular points we know about the concept of dipole moment, we can do any such type of questions. So n number of questions. This is very, very important So based on this concept only, so many questions they will ask in the exams. Thank you. I'm signing. Thank you very much.